In this video we'll discuss the trigonometric basic equation cosine x equals a. We'll discuss how to solve the basic equation, and we'll look at one example where we solve the basic equation cosine x equals 1 over 2. Alright, on this overview here you can see the graph for the periodic function fx equals cosine x. If I look at another function, which I can define as gx, and that is equal to a certain number a, and if I plot that same function, the graph for this function gx equals a, into this overview here where I also have the function fx equals cosine x, then we see that if a is in between -1 and 1, we will actually have intersection points between the two graphs fx and gx. So that's actually where we can see that if we are looking at these two functions, fx equals cosine x and gx equals a, and looking at the intersection point between these two graphs, that's the points I will indicate here. Then we can find those intersection points if we find the points the two graphs have in common, and that must be when fx is equal to gx. Recall from the first semesters that intersection points between two graphs will be when they have points in common. So when the two function values fx is equal to gx, then we have seen that fx is defined as cosine x and gx is defined as a. If we can solve this equation here, we will exactly get the points of intersection between fx equals cosine x and gx equals a. And that's why we have this restriction to a here, that a has to be in between -1 and 1, because if it's lower than -1, or if a is greater than 1, then they will never intersect with fx equals cosine x, as you can see, and thereby we can conclude that we will not have a solution to the basic equation cosine x equals a if a is not in between -1 and 1. As you recall from when we defined cosine, we do not have any restrictions to x. X is equal to all the real numbers, which you can also see here on the graph for f. Alright, so how do we solve cosine x equals a? Well, let's look into one example, and then afterwards we will look at the general picture. Here we have the unit circle, and as you hopefully recall, cosine value we'll find on the x-axis. So if we look at this example here, where we should find the solution to cosine x equals 0.5, and we recall that we don't have any restrictions to x, then we see that what we're actually looking for is angles of x, which will give me a cosine value which is 0.5. And we also remember when we talked about cosine that will also be the negative angle minus x here, which also will give me a cosine value which is equal to 0.5. So that is, when we take the inverse operation on both sides, we will actually get plus or minus inverse cosine 0.5. Then we have both the positive solution, the positive angle, and the negative angle included. But we have a bit more, because if we look at the positive solution here, and every time we take one journey around our unit circle, that is, we add 2 pi to that, then we get back to a new angle which also will have a cosine value which is equal to 0.5. And if we add another angle to another journey on the unit circle, then we'll get back to a new angle which will also have a cosine value which is 0.5, and so on and so forth. Every time we take one journey around the unit circle, we'll get back to a new angle which also will have a cosine value which is equal to 0.5. It's the same case with the negative angle, of course, here, that every time you add 2 pi to that, a 1 journey which is equal to 1 journey around the unit circle, you will get back to a new angle which will also have the cosine value which is equal to 0.5. So if we should conclude, the total solution to cosine x equals 0.5 will be x is equal to plus or minus inverse cosine 0.5 plus p times 2 pi, and p must be one of our integers. Alright, so now we're almost there. We just need to calculate what is inverse cosine 0.5. That is equal to pi divided by 3. So the total solution to cosine x equals 0.5 must be x equals plus minus pi over 3 plus our period p times 2 pi, and p is one of our integer. So that is the total solution to cosine x equals 0.5. So if we look up at the general picture here, then we see that if we have a basic equation called cosine x equals a, where we have the restriction that a has to be in between minus 1 and 1 for this equation to have solution, then we can generally say that the solution is equal to x equals to plus minus inverse cosine a plus p times 2 pi, our period, where p has to be part of our integer. So that's how you solve the basic equation cosine x equals a. In the next videos we will look into how we solve the basic equation sine x equals a and tangent x equals a.